Algebra Unit 10, Lesson 6, Note 6, Solving Quadratics by Factoring. A quadratic equation can be written in the standard form ax squared plus bx plus c equals 0, where a cannot equal 0. Some equations of this form can be solved by factoring and then using the zero product property. This means that one side of the equation must be 0 before factoring and solving. So the idea here is you want to get 0 on one side of the equal sign. So let's take a look at letter A. It's already solved for 0, so what we're going to do is we're going to factor x squared plus 7x plus 12. Now it is a trinomial. There is no greatest common factor, and because it's a trinomial, I'm going to do MAM. The coefficient of x squared is 1, the leading coefficient, so I can just do regular MAM. My m is 12, and a is 7. So I'm looking for two numbers that multiply together to give me 12 and that add to 7. Well, 4 times 3 give me 12 and add to 7. So x plus 4 times x plus 3. So far, nothing is really different from factoring. But here's the new information. We want to know what the roots are of the quadratic. In other words, where the quadratic equation, where the parabola crosses the x-axis. To do that, we actually can take our factors and split them up by creating a t-chart. Now we have equals 0 over here, so I'm going to set each factor equal to 0. X plus 4 equals 0, and x plus 3 equals 0. Now I have two one-step equations to solve. Let's do the one on the left. I'm going to subtract 4, and I get x equals -4. And on the right, I will subtract 3 and get x equals -3. That means that on my graph of this parabola, it actually crosses the x-axis at -4 and -3. So it would look something similar to that. To write this answer, we're going to use our brackets. Put your answers in numerical order. Those are the roots. Let's take a look at B. X squared minus 9 equals 0. We have 0 on one side. Perfect. Now let's look to factoring. We cannot pull out a GCF, and we have two terms. It is a difference, and both x squared and 9 are perfect squares, so we are going to use dots. With dots, we take the square root of each number, so the square root of x squared is x, and the square root of 9 is 3. Make one plus, make one minus. Bring down the equal 0. Split up your factors and create two different equations. Sometimes you can have more than two equations. Depends on how many factors you have. Set them both equal to 0. Now solve. -3, x equals -3. On this side, we can add 3, and we get x equals +3. So your your roots are -3, 3. You could also write them as plus or minus 3. Either or is sufficient. Letter C. X squared minus 2x equals 0. We have it equal to 0, so we're good there. And we need to pull out a GCF. They both have an x in common. So I can pull out x, and I'm left with x minus 2 equals 0. X minus 2 cannot be factored anymore, so I'm done factoring. I'm still going to do a t-chart, and I have x as a factor and x minus 2 as a factor. We're still going to do the same thing and set them both equal to 0. So x equals 0, and x minus 2 equals 0. Now the first one's already solved. I don't have to do anything, so my first root is 0. My second root, I will add 2, and I get x equals 2. So the roots here are 0, 2. Again, they can also be called zeros or x-intercepts. Let's look at E. This time I don't have 0 on one side, so I need to make that happen. My x squared is positive, so I'm not going to move x squared. I'm going to leave everything on that side. So I'll move this negative 35. To get rid of negative 35, to bring it over, I need to add 35. So I have x squared minus 12x plus 35 equals 0. It's important when you're rewriting it to make sure it's in standard form. In other words, your x terms are descending. Your variables, the exponents will be decreasing. Okay, I do not have a GCF, but I do have a trinomial. So let's do MAM. M is 35. A is negative 12. Negative 7 and negative 5, when you multiply them, give you positive 35. And when you add them, you get negative 12. So when I factor it, it's x minus 7 times x minus 5 equals 0. Do your t-chart. X minus 7 equals 0. X minus 5 equals 0. Add 7. This one you need to add 5. Oops. So your solution, or your roots, is 5, 7. Again, make sure it's in numerical order. Letter F. Again, we need to get 0 on one side. And if we look over here, my x squared is positive, so I want to bring everything over to the left-hand side. I'm going to do that by subtracting 10x. And again, I want it in standard form. So I have my x squared term, then my minus 10x, then plus 25 equals 0. When we factor it, we need to check for a GCF, and there is not one. I have a trinomial, so I'm going to use MAM. M is 25, A is negative 10. Negative 5 times negative 5 equals positive 25, and it adds to be negative 10. So this factors into x minus 5 times x minus 5, which equals 0. T-chart. X minus 5 equals 0, and x minus 5 equals 0. Solve them. Plus 5, x equals 5, plus 5, x equals 5. Now, because the roots are the same, I only have to write it once. If you're wondering what that would look like, let's say that dash is 5, it would look something like that. It would only touch in one spot. Letter L. I have 0 on one side. Now let's check for a GCF. They do have 2 as a GCF, so let's pull that out. I'm left with x squared minus 4x minus 5. The inside is a trinomial, so I'm going to use MAM. M is negative 5. A is negative 4. So our factors are negative 5 and positive 1. Bring this 2 down. When you factor that trinomial, you get x minus 5 times x plus 1. This time I have 3 factors. I have these 2, but 2 is also a factor. So something a little weird happens here. I still set them all equal to 0. And you should notice an issue with that first one. 2 does not equal 0. So I'm going to put a not equal slash through that equal sign and disregard that. For this one, I will add 5, and I get x equals 5. And for this one, I will subtract 1 and get x equals negative 1, making the roots or zeros negative 1, comma 5. Letter O. So this one, we have equals 18, so I don't have 0. But I also have these parentheses that I need to take care of. So the first thing I would do is distribute. X times x is x squared, and x times negative 3 is negative 3x. Bring down the rest. Now I can subtract the 18 and make our trinomial x squared minus 3x minus 18 equals 0. There's no GCF, but I have a trinomial, and I can use MAM. M is negative 18, and A is negative 3. Negative 6 times 3 is negative 18, and when you add them, you get negative 3. The factors are x minus 6 and x plus 3. Do your t-chart. Set them both equal to 0. And solve. Plus 6, x equals 6, minus 3, x equals negative 3. Making your roots negative 3, comma 6. I want to look at one more on this page. Let's look at Q. What I need to do this time, I have to distribute on both sides. So I have x squared minus 6x equals 4x plus 24. On this side, I have a positive x squared, so I need to move these two terms over to the other side. You can actually do this in one step. You can subtract 4x and subtract 24 in one step. So minus 4x minus 24. Leaving me with 0 on the right. On the left, I have x squared. These two are like terms, so minus 10x minus 24. Here I can use MAM. M is negative 24. A is negative 10. Negative 12 and positive 2 are my factors. So x minus 12 times x plus 2 equals 0. T-chart. X minus 12 equals 0. X plus 2 equals 0. Add 12. I get 12 for the one root. Subtract 2. And I get negative 2. Making the roots negative 2, comma 12. These next three are ones that require factor by grouping. So I will do one of them with you. I'll do T. I'll do the one in the middle. It's already equal to 0, so I don't have to move anything around. There also is no GCF. So I do have to do MAM, but because my leading coefficient isn't 1, I know I'm going to end up splitting this middle term and factor by grouping. So M is 60 and A is 17. With 60 and 17, 5 times 12 is 60, and when you add them, you get 17. So again, that's my middle term. 3x squared plus 5x plus 12x plus 20 equals 0. Group. I can pull out an x in the first part, and I'm left with 3x plus 5. And in the second one, it looks like I can pull out 4, and I'm also left with 3x plus 5. My common factor is 3x plus 5, and the remainder is x plus 4. So these are my two factors. You're still going to do a t-chart. 3x plus 5 equals 0. X plus 4 equals 0. Subtract 5 from both sides. I have 3x equals negative 5. And this one's a two-step equation, so I'm going to keep solving for x. I have x equals negative 5/3. On this side, I will subtract 4 and get x equals negative 4. Leaving my two roots, negative 4 and negative 5/3. cross multiply to solve the following proportions. So we're going to use cross multiplication. I'll do a couple of these with you. Letter A, going to multiply those together and multiply those together. So it would look like this. X times x minus 3, make sure that's in parentheses, equals 7 times 4. On the left, I will distribute x squared minus 3x equals, and 7 times 4 is 28. I still need to get 0 on one side, so I will subtract 28. X squared minus 3x minus 28 equals 0. It's a trinomial, there's no GCF, so I have to use MAM. M is negative 28. A is negative 3. Negative 7 and positive 4 are my two factors. So it's x minus 7 times x plus 4 equals 0. Do a t-chart. X minus 7 equals 0. X plus 4 equals 0. Add 7. We get x equals 7. Subtract 4. We get x equals negative 4. Making the roots negative 4, comma 7. Okay, I'll do one more with you, and I'll do letter F. We're still cross multiplying. So I have 3x minus 2 times x plus 2 equals x times 3x plus 3. Lots of distributing and most likely combining like terms. 3x times x is 3x squared. 3x times 2 is 6x. Negative 2 times x is negative 2x. And negative 2 times 2 is negative 4. That takes care of the left. On the right, distribute 3x squared plus 3x. Okay. So I'm going to move everything. Actually, I'm going to combine these like terms first. I have 3x squared plus 4x minus 4 equals 3x squared plus 3x. I need to get 0 on one side, so I will just move everything from the left over. Again, you can do this in one step. I would subtract 3x squared, and I'd also subtract 3x. Minus 3x squared minus 3x. Those cancel and leave me with 0. On the left-hand side, 3x squared minus 3x squared actually cancels out. 4x minus 3x is just x. Bring down the minus 4. So this one, I only end up with a one-step equation when solving it. So I will go ahead and add 4 to both sides. And I get the only root as being 4. So that one I didn't even have to do any factoring, just simple solving got me to my root. Go ahead and finish the rest of these on your own.